In this video, we are going to talk about the inverse trigonometric functions. So before we get into the details, we just need to do a tiny little bit of review from college algebra about inverse functions. So the first idea that I need to remind you of from college algebra is of what a one-to-one function is. So a function is one-to-one if two different inputs to f of x always produce different outputs. All right, so that's a version of the definition. And so let's just take a look at that, right? We have a function here, a fairly simple one, f of x equals x squared. And here's its graph over here. And what I'm going to do is have two different inputs. So I'm going to plug a -2 into the function, and I'm going to get an output based on that. And I'm going to plug a 2 into this function. So if I plug a 2 into f of x equals x squared, I get a 4. Okay? So what you see is here I have two different inputs, -2 and +2, and they give the same output. All right? And so that violates this definition. So this function, f of x equals x squared, is not one-to-one. There's two different inputs that give the same. But if it's one-to-one, then two different inputs should always produce two different outputs. So f of x equals x squared is not one-to-one. Okay, and so a pretty nice way to think about one-to-one with the types of functions that we're looking at is with the horizontal line test. And you probably talked about that in college algebra. So a one-to-one function is going to pass the horizontal line test. Every horizontal line is going to intersect the graph in at most one point, right? And so you can see here, right, you would just think about a horizontal line and being able to move it around. And then you're looking, hey, where does this horizontal line intersect the graph of the function that I'm looking at? And so here you can see it doesn't intersect the graph, and that's okay. If I move the horizontal line here at 0, then I get one intersection point, and that is right at 0, 0, and so that's okay, right? But if you'll notice, the moment that I move that horizontal line higher above the x-axis, I'm going to start getting two intersection points. And again, so what that would mean is that f of x equals x squared would fail the horizontal line test, and it's not one-to-one, okay? And just to show you how this connects up with this idea here before, if I raise the horizontal line to a height of 4, so if I put it up here, and then look at the x numbers where it intersects, you can see one is -2, and the other is 2, okay? And so those were the inputs that led to this same output. I had two different inputs leading to the same output, and what that will mean is that for these kinds of graphs, the horizontal line will cut through that graph in more than one spot. Okay, so that's what one-to-one is about. And the reason we care about one-to-one is because one-to-one functions have inverses. Okay, and so the definition of inverse, right, is that two one-to-one functions f and g are inverses of each other if f of g of x is equal to x and g of f of x is equal to x. And so you have to kind of remember back to composition of functions for that definition to make sense. But let's just kind of explain it in a different way. Two functions are inverses of each other if I take any input, and here I have a 4 as an input, and I am plugging that into f, and the output I get is 3, right? If I take that output and plug it into the inverse, so take the output of one function and make it the input to the other function, the output of that will be the original number that we started with here as the input to the first function. So for instance, if I plugged in a 17 here, I get a 29, right? If I take that 29 and I plug it into the inverse, right, I should get that number back. And likewise over here, if I take a number and 55, right, and I plug it into this function and I get an output of 30. If I take that 30 and I plug it into the inverse function, right, and look at its output, it will be the input from the first step in there. So in a sense, right, the inverse functions undo each other. All right, and a function having an inverse is important, you know, for a lot of times we're trying to solve equations involving the other function, its inverse. Okay, so that's what an inverse is, and that's what we're concerned about. We want to try to find inverses of the trigonometric functions. Okay. And the problem is you can see, right, the trig functions are not one-to-one. None of them are. In fact, in a big way, they are not, right? If I take any horizontal line, right, I'm going to be able to find one that cuts through any of the trig functions in infinitely many places, okay? And so that's a problem. These functions are not one-to-one. Cosine's not one-to-one, right? Tan's not one-to-one, because they all miserably fail the horizontal line test. So that's a problem, right? Because in order to have an inverse function, you have to be one-to-one. All right, and so, but there's a trick to kind of get around that issue, and I'm going to show you that trick right now, and it's important to understand. So the inverse functions, or the trig functions, are not one-to-one. So what they decided to do was just chop them down. If I use the entire graph, okay, it's not one-to-one. But what they said was, okay, we can cut this down and only look at the trig function on a little piece. And so for the sine, they decided, okay, let's do that on the piece from between minus pi over 2 and pi over 2. So the full sine looks like this, not one-to-one, right? And so they said, let's cut it down to just this little piece here in the middle. And if you look at that little piece, every horizontal line either doesn't cut it or cuts it in exactly one spot. Okay, so if you trim down the sine function to just this little piece, it is one-to-one. And so then, right, you can create an inverse function for it. All right, and that inverse function of this little piece is called the inverse sine function. Okay. So the inverse sine function, it's denoted in two ways, right? It's denoted as sine inverse, just like kind of you did in college algebra, f inverse of x, like so. All right. On Desmos, you can't type it in that way. So with Desmos, you have to type it in as arc sine, which is another way that you will see it written. Like so. So the arc sine function is just a really small little function. It looks like that, and that's it. Okay, its domain is from -1 to 1, and its range is from minus pi over 2 to pi over 2. All right, so domain is just from -1 to 1, so along the x-axis just here, and the range is from minus pi over 2 up here to pi over 2. Okay. And so we're going to talk about the inverses of the other functions as well, the cosine function. Again, it is not one-to-one, right, at all. So they play the same trick, and they cut that down from 0 to pi. So they just use this piece right here. And that part is one-to-one, and so it has an inverse. Okay, and so that's what the inverse function looks like for the inverse cosine. Again, it's just a really small little graph, okay? Which I always found to be kind of weird when I was learning this, because you know, the The trig functions are periodic and they just kind of keep repeating over and over again forever, but the little inverse functions are just little small pieces of graphs, at least sine and cosine. We'll see for tangent, it's bigger than this in a sense. Okay, and so the domain of the inverse cosine function, again, when I write it down on paper or on the board or on the computer screen, I'll be writing it as this cosine inverse, right, with the little -1 here. Okay, but on Desmos, it'll be written as arc cosine. You can see that the domain is from -1 to 1. So here, -1 is the leftmost point on the domain, and then over here on the 1, and then the range is from 0 to pi. Okay. Now, one important thing to notice here, right, is that this -1 in algebra class, you're used to having x to the -1 as 1 over x. When you're using this -1 for the inverse functions like this, it does not mean that, okay? Because 1 over it does not mean 1 over cosine, because that is what we call the secant function. The secant function is totally different from the inverse cosine, so you have to be very, very careful about that. All right, and so the last one that I'm going to show you the graph of is for tangent. And tangent, again, right, is definitely not 1 to 1. In fact, every horizontal line cuts through the graph of tangent in infinitely many places, right? So that is really bad as far as being 1 to 1. So again, we're going to play the same trick. We're going to trim down the tangent function to a place where it is 1 to 1. And so the place where they choose to trim it down is to this one right in the middle, right? To that branch right in the middle. And you can see now it is 1 to 1. No matter if I only look at that small little piece, right, I can only, every horizontal line cuts the graph in at most one spot. Okay? So that is where we start calculating the inverse from, or the tangent from. And when we do that, we get this function here in green. Okay? So that's what the inverse tangent function looks like. Remember, on Desmos it's arctan, but when I write it on down on paper or here on the computer screen, I'll be writing it as tan inverse with a -1 up in here between the name tan and the parentheses and the variable that's in here. So again, do not confuse that with 1 over tan. It means a totally separate thing. Okay, 1 over tan is what we call cotangent. So cotangent, right, and tan inverse are two completely different things. Okay, they are not the same at all. The domain of the inverse tan function is -infinity to +infinity. Right, so it has a unbounded domain, unlike inverse sine and inverse cosine. And the range of the tan inverse function is from -pi/2 to pi/2. So if I look, the graph never gets above, of tan inverse, never gets above pi/2. Oops, that's y equals pi/2. So it never gets above this purple line, and it never gets below y equals -pi/2. So tan inverse is trapped in between those two horizontal lines. It never gets higher than this, never gets lower than this. And so that makes it useful in a lot of different situations in your later on math classes if you have to take any of those. Okay, all right, so that is the idea, right, between of the inverse trigonometric functions. And in the next video, I am going to show you how we calculate those out.